Hi everyone. In the previous video we assembled the drone, and in this video we are going to set up the flight controller and assign various functions to it. So without wasting any more time, let's begin the video. I am using the Radiolink mission planner software. Since we are using a Radiolink flight controller, it is recommended to use the mission planner software provided by Radiolink. First we are going to upload the firmware on our flight controller. So here we are using a quadcopter firmware because we are building a quadcopter. So let's upload the firmware onto our flight controller first. So now over here we can see it is showing upload done. This means that the firmware has been successfully uploaded onto the flight controller, and now we are going to connect the flight controller with our laptop. Select the COM port and click on connect. Now that our flight controller has been connected to our laptop, we will go to mandatory hardware and then select the frame type. So we are using a quadcopter, so we will select the quadcopter frame type. Next we are going to go to initial tune parameters and then set the battery cell count to 3 because we are using a 3 cell LiPo battery. Now we will do the axle calibration. For that, first we need to place our drone on ground level, and then we will follow the instructions shown on the screen. Place vehicle on left, so we will tilt the vehicle towards the left. Then now it is saying place vehicle to right. Now we will tilt the drone to the right side, and after that we will click done. Nose down. Basically nose down means that the drone will point towards the forward direction, so we have to tilt the drone in the forward direction and click OK or done. Now it is showing nose up. This means the drone will be facing the backwards, so we have to tilt the drone backwards. On its back means we have to place the vehicle upside down. It is showing calibration successful. Then we will calibrate the level, and now our axle calibration is complete. After axle calibration, we will now do the compass calibration. Over here there are 3 compasses, but we are using only 2. One is the internal inside the flight controller and the other is the one provided in the GPS. So we won't be requiring 3, so we can just cancel the use compass 3 option. If you are not using the GPS, you may use only one compass, that is use compass 1. But I am using the GPS, so I'll keep compass 1 and compass 2, and then we will click start, and after clicking start we have to rotate the drone in every single direction so that it captures all the motion and we can calibrate the compass. I am using two compass, that's why there are two bars. If you are using only one, then there will be one bar. When both the bars hit green, that means the compass calibration is successful. And after compass calibration, we have to reboot the drone. So to reboot, we will click on the button that says reboot, and then after a few minutes when we hear the drone beep, we are going to connect it again. After compass calibration, now it is time to do the radio calibration. So for this we are going to need a transmitter. So first we will switch on our transmitter. Now you will notice that the transmitter is on, but no recordings are being shown on the screen. Like when I'm moving the joystick, nothing is being shown on the screen. This is because we are using the wrong mode. For Crossflight we need the PPM mode, and right now it is set in the PWM mode. So let's change the mode to PPM. Now as we change to PPM, you can see that all the readings are being shown. So now we can calibrate the radio as well. So to calibrate the radio, first we'll have to click on calibrate radio. And then when you see the red lines appearing on the bars, move the joysticks and the switches to their extreme point. Now after that, click done and our radio calibration will be complete. We are not using servo output or serial ports, so now we will directly jump to ESC calibration. For ESC calibration, we will follow the instructions shown on the screen. First we will press on calibrate ESC, and then we will disconnect the drone and we will connect the battery. When you hear the buzzers on the drone beep, that means that the ESC calibration is successful and complete. After ESC calibration, now it is time to set the flight modes. On my transmitter I am using channel number 5 as my flight mode changing switch. So on the first one, it all as you can see, all of them are showing stabilized. So on the first one I am going to put altitude hold. On the second flight mode I am going to set pause hold. This only works with the GPS. So if you are not using GPS, then you should do some other flight mode. And on the last flight mode I am going to do return to launch. If you are not using your GPS, this won't work yet. So it is better to put the flight mode as land on the third one. For failsafe, we will keep that to enabled always RTL. If you are not using a GPS, then you should change that to land. This means that whenever the drone executes a failsafe, the drone will return to launch on its own. So with that, the setup of our drone is complete, and now our drone is ready to fly. So now we have successfully built our Crossflight drones. So that was all for this video. I'll be back with another video and another new exciting project. Till then, take care. Bye bye.